University of Science and Technology. We are the second year student. This morning, we would like to introduce to you an interesting topic. The information we give you today will help you more understand about a big problem of physics, which maybe the understanding is not clear. Now, I want to show you something by giving to you some pictures of this problem which I'm talking about. As you can see, a falling apple, springs. Sorry, can you guess what topic I'm talking about? Do you have any more ideas? Right, I'm talking about the potential energy, and especially the relationship between conservative force and potential energy. In my presentation, I will talk about the introduction of our topic, and my friends will talk about the conservative force, potential energy, the relationship, and of course application and summary. The purpose of our presentation have three main points. Firstly, we will give to the audience more information about potential energy and the relation between potential energy and conservative force. Secondly, we will build a research for studying some more difficult problems about potential energy. And finally, we will give to the audience a new method to solve many exercises. Our presentation has four main parts: Part A, conservative force; Part B, potential energy; Part C, the relationship; and Part D, application. We will start by introducing the definition of force field, and we will end by answering the question. We will talk about 25 minutes. Please feel free and keep silent while we are talking. And I think handout is very useful for you to catch our presentation and to understand our presentation. And now, my friend Mr. Cong will give to you the handout. Mr. Cong, please. Okay, let's start with the force field. So, what's the force field? A system which consists two or more of others that exert forces on one another. The space a force exists is a force field. So I've just finished my talk. Now my friend Cong will continue by talking about conservative force. Mr. Cong, please.
Okay, hi everyone. Let me introduce myself again. I'm Cong, and the topic of my presentation is relation between conservative force and potential energy. So now I talk about conservative force. Conservative force is special force, but also it has property like any force. For example, when you throw the ball up in the air, it slows down a kinetic energy. It converted into potential energy, and if there are no air distances, it moving air fast when you catch it and when you throw it. One more example. A glider move on wrist net horizontal. It swing compress and gyroscope. But then this glider move on bounce back with the same speed. In both examples, that's the way conversion between potential energy and kinetic energy. So why? Of course, the work is this way. Okay, this is the conservative force. Like, once again, the force that offers the opportunity of two-way conversion between kinetic and potential energy is conservative. Like any force, you know, conservative can do work, and this work have properties. There are three properties. First, it can always be grasped by differentiation between initial and final value of potential energy function. Secondly, it's reversible. And thirdly, is independent of the part of the body and depends on the starting and ending point. And that's why when starting and ending point is the same, the total work is 0. Okay, that's all information about conservative form. But inertial, all the form is not conservative. So one concept you should know is the form that the work is done not satisfy all of the properties is non-conservative. Non-conservative. Yes. To change your understanding, I have a question for all of you. Christian is conservative or not? Yes, Christian is not conservative. So now I prove it in example. Let me see the picture example. When you want to close it from point 1 to point 2. Yeah. If you push in a straight line from point 1 to point 2, the work you done equal minus friction work and equal VK multiply mgs. And if you push in the left part from point 1 to point 2, the work you done equal minus friction work and equal VK multiply mg multiply m1 plus m2. So I have question. Can you compare to value in this case? Yes, different. So the frictional work depends on the part. So therefore, friction is not conservative. You should remember friction is not conservative. It is very important. Okay, that's all I wanted to say about conservative form. Before I move on, I'd like to get the main point. The work is done depends independent of the part and depends on the starting and ending point is conservative. I've done my part, and then Mr. Vu will talk about potential energy. We believe. Thank you.
Hello everyone, first of all, let me introduce myself. My name is Vu, and in this part of our presentation, I will talk about the potential energies. I think that potential energies are really to you because you learned this in high school, and I'm sure that all of you are still remember something for it. But now I want to present this problem to you more understand for it and can show some question around this problem. First of all, I want to give you definition of potential energy. Potential energy is whenever the object has the position within the field force. Yes, and you understand? I think it's very soft and very clearly to understand. But in the definition of potential energy, I want to express that potential energy depends on the position. And in the next part of my part, I will explain why potential energy depend on the position. And the potential energy is classified by the gravitational potential energy and the kinetic potential energy. So now, let us start with the gravitational potential energy. Gravitational potential energy is stored energy described by the object position in gravitational field. And now I will explain why it depends on the position. And you can see in this slide. This slide is way too beautiful of the gravitational potential energy. I think it's very easy to understand. Are you still understand? No, you don't. As I can explain what in the chapter 6 we have work done with that we equal to F multiplied F. And in this case, the force itself, the object is a gravitational gravitation force. Also, F equal to M multiplied Z. So yes, and finally we have the gravitational potential energy Ug equal to M multiplied Z multiplied Y. And in this form, you can see gravitational potential energy depend on the position Y. And in this form, you can see in this slide as have the minus signs in this equation. Can you help me explain why I have a minus in this equation? Yes, I will answer this question. Because if we are increasing the potential energy objective relates to probabilities of, so we have the minus here. It's very necessary for you because many students when apply this form to do exercise when the mistakes, so if you choose carefully when the apply to some exercise. I have another question to you. When I threw up the rope in the up the air, and which object contain the potential rocks or the air?
I think potential energy of
Yes, as many people think that's potential energy of rocks, but potential energy is relationship between the rocks and the air. So the answer this is that both rocks and the air both proposing the potential energy. Are you satisfied? Yes. Let's move on the electric potential energies. Electric potential energy is energy stored in spring when it's compressed and it's being or compressed. Yes. The same similar to the potential potential energies. The electric potential energies also depend on the position. And this slide is the way to view the form of electric potential energy. You can see this slide. And the final form we also write as Us equal to 1 half K multiplied H squared. K is the spring quota. It also depends on the position. So let's bring me in the end of my part. And before moving into the next part, I want to summarize that potential energies depend on the position, and potential energy have two kinds of gravitational potential energy and electric potential energy. Yes, and as now, I hope we will continue with our presentation. Please.
Okay, thank you. Hi everyone, my name is Cong, and now I will present my part. And as you know, our topic today is relation between conservative force and potential energy. And my part is relation. So my part is the most important part in our presentation today. So gentlemen, please pay more attention for me to catch our presentation better. Okay? And before studying about this relation, I want to review some special formulas of conservative force and potential energy. Firstly, gravity. And when we choose the positive direction is up, so the force function of gravity is P equals minus mg. And also the corresponding potential energy function is Uy equals mgh, where h is the height from potential origin. And the next one is elastic force. The force function here is Fx equals minus Kx. And also the corresponding potential energy here is Us equals 1 over 2 Kx squared. It is easy to know, and our problem today is the potential energy function is given. So how to determine the corresponding force function? And in this case, we only consider the conservative force, okay? And now we will solve this problem right now. Firstly, we consider the simplest motion. It is motion along a straight line OX. And we denote Fx is the force function along x-axis. Us is potential energy function. And we know that at any displacement, the work done by a conservative force equals the negative of the change in potential energy. So in this case, we have this formula W equals minus delta U. And now we consider a small displacement delta S. And the work done by conservative force in this case will be approximately, remember, approximately equals minus delta O. And we have this formula Fs delta X approximates minus delta U. And now we consider when delta S approaches 0. And then we will take a limit, and then we will have this formula. This formula is very important. Fs equals minus du over dx. And I explain more details and more steps in our handout. You can see in the handout in your sheet paper. And in conclusion, this is the most important. Our relationship is Fs equals minus du over dx. Okay? And as a check, we will check the formula of elastic potential energy. We know that the potential energy function of elastic force is Us equals kx squared. And now we will use this formula to find the formula of force function. And the result here is Fs equals minus kx. Okay? It is true, of course. And now, to discover some interesting information of this formula, we will expand it into 3 dimensions. We know that in 3 dimensions, any vector in 3 dimensions can be expressed by the sum of 3 components. And as you can see here, vector F can be expressed by the sum of 3 components: Fx, Fy, and Fz. And also, similar to 1 dimension, we will achieve this result: Fs equal minus du over dx, and also Fy and Fz here. And we can use the unit vectors to express the formula of vector F. And I express the formula of vector F here, as you can see. And we will use this slide to shorten the formula of vector F. This slide is called gradient. And in conclusion, in 3 dimensions, vector F equals minus gradient times U. Okay? And that's all my part. Before we continue with the next part, I want to summarize, repeat the main point, what is the most important in my part. The most important in my part is relation. And in 1 dimension, the relation here is Fs equals minus du over dx. And in 3 dimensions, the relation is vector F equals minus gradient times U. Okay, remember that, so important. And now Mr. Hung in my team will give you some information about this method and what are the advantages or advantages of this method. Hung, please.
Okay, my friend had just talked about the relationship between potential energy and conservative force. So when you see a formula or definition, you will wonder that what is it used for, or why do we have to know this? In my part, I would like to explain for you the application of this relationship. And after doing research about this topic, we realized that this is a new method of calculation in some physics exercises, especially the function fx, as you see. And in my part, I will show you some advantages and some disadvantages of this method. Let's go into more detail. Begin with example. As you can see here, a rocket with an engine produce a constant force F, and the engine can change direction of motion unpredictably. So the motion is very complicated, very complex, and I used to wait to show this problem, Newton's second law and the function of relationship. The question here is, what is the total force acting on the rocket at that position? So, about Newton's second law, because the motion is very complicated, so it is very difficult to determine the direction of velocity of the rocket at this position. Even we know this value, we have to project all the forces acting on the rocket and do blah blah blah. It's very long and a little bit complicated. So what about the relationship? Consider the function fx is equal to minus du over dx. We obtain immediately the answer of this question. So in this case, which one is better? I know you know the answer of this question. In conclusion, the advantages of this method are we don't need to carry a lot of information of the motion, and we don't need to know all the characteristics of this motion. And the second is absolutely faster and it's much shorter. The last one is more accurate. So it's powerful, it's beautiful. So why don't we forget the Newton's second law? Let's get back to the example. What happens if the question here is how much the rocket traveled, or what time from the starting point until the rocket reached this point? I know that question cannot show by the relationship, and we have to apply the Newton's second law. So the advantages of this method are we cannot know all the information of the motion, such as velocity, direction, and magnitude, time. And the second, we can apply this for some special cases. It's not general like Newton's second law or the law of conservation of momentum. There are advantages and disadvantages. This is the end of my part. And before we stop, I'd like to capture our main thoughts again. There are conservative force, definition, properties. Similarly, potential energy, definition, classification, and properties. The third one is relation between potential energy and conservative force. And the last one, the application, advantages and disadvantages. If you feel excited about our topic, maybe some reference here are helpful and useful for you. And I hope that our information today are helpful for you to solve more problems, more exercises, and discovering more in the beautiful world of physics. Again, thanks for your coming here today. Thanks for the attention. Question, please ask us question, and one of our members will stand and answer this.
Say that time for question.
Any question, please? Feel free for asking question.
Wait.
Any confused about the formula? I'm sorry, can you repeat the question?
How you can determine the position of the motion in the
Okay. You remind me that I forget one point in my presentation. forget that we suppose that the origin of potential energy is here, and at that point we can easily obtain the position and the change of potential energy.
Okay. Is satisfied you? No question?
Well, there won't be any more question. Thanks again. Thanks again. Now to the comments.
이건 뭐냐?